Hello everyone, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this January 2026 lecture series, we are discussing about biomedical transducers and sensors. Now we are going to discuss about the characteristics of measurement system dynamic. First of all, what are dynamic characteristics? Why they matter? Here, dynamic characteristics describe how a measurement system responds to time varying inputs. Unlike static characteristics, it deals with the steady state behavior. Dynamic properties determine how quickly and accurately a system can track changing physiological signals, which includes a response time and speed, frequency response behavior, stability, and damping. Why they matter? Biomedical signals are inherently dynamic, like heart rate changes, blood pressure fluctuates, and neural signal pulse rapidly. And a measurement system must capture these changes faithfully without distortion or any delay. Here, this is critical for real-time patient monitoring and diagnosis. See here, here I've mentioned essential dynamic characteristics of measurement system, which includes time constant, frequency response, rise time, and damping ratio. Time constant is it defines how quickly a system reaches 63.2 percentage of its final value after a step input. Here, first order systems, we have a single exponential response and faster response, which leads to smaller time constant. Rise time is TR. Here, the time required for output to rise from 10 to 90% of final value. It controls oscillation in second order systems. It indicates system speed and inversely related to bandwidth. Frequency response describes a system behavior across different input frequencies. Bandwidth, a range of frequencies accurately measured, and phase shift, time delay at different frequencies. And our damping ratio, here we have underdamped, critically damped, and overdamped. Underdamped, we have overshoot and ringing. Critically damped, we have faster settling without overshoot. Overdamped, slow, no overshoot. These are all the essential dynamic characteristics of measurement systems. Time constant tau, rise time TR, frequency response, and damping ratio. See, in our defined part, the behavior of a measurement system when subjected to time varying inputs reveals its dynamic characteristics. Here, different kinds of input helps to characterize the specific performance. Here we have step response, impulse response, ramp, and frequency response. See, and thus, dynamic characteristics in real-world biomedical applications, we have ECG monitoring systems. In this part, electrocardiogram systems must have adequate bandwidth. It ranges from 0.05 to 150 Hz to capture the PQRS complex waves and T waves accurately. Here, the rise time under 10 milliseconds is critical for detecting rapid cardiac events. Here we have blood pressure transducers, temperature sensors, and pulse oximetry for accurate prediction. And here I've included one activity for analyzing dynamic response. Here our objective is to understand how dynamic characteristics affect measurement accuracy by analyzing real biomedical sensor response. Our first one is setup, data collection and compare and analysis, and third one is application discussion among peers. See, in the assessment part, we have dynamic characteristics quiz, which is taken from GE Healthcare. Here, I've included 4 questions. First one is, what is the relationship between rise time and bandwidth in a measurement system? And question 2, a second order system with a damping ratio, which is equal to 0.4, will exhibit what? And why is frequency response important for ECG measurement systems? Ask question 3. Question 4, I've included which dynamic characteristic indicates how quickly a sensor reaches steady state. See, Here, the key takeaways are dynamic versus static and critical parameters and application specific design. In summary part, we have time domain, frequency domain, system orders, and performance. Time domain includes time constant, rise, settling, and overshoot. Frequency includes bandwidth, response, phase, and resonance. System orders, we have first, second, and higher order systems. Performance, it includes accuracy, precision, linearity, and sensitivity. Here, at last, I've added some references for dynamic characteristics of measurement system. Definitely, it will help you to understand the dynamic characteristics of equipments as well as systems. Thank you. Thank you all.